All right, this is for Physics CP. It's Monday, April 12th, 2021, the first day of students being back on campus after a full year of pandemic-induced shutdown of our public education system. Here during the fourth quarter of this school year, I'm going to be teaching about the entire universe, uh, the sun, how it works, the stars, our understanding the universe. And so here's kind of a vocabulary list or topic list of what I want to cover: age of the Earth, the sun, something called Ober's paradox, and so forth. To start us off, I'll tell you the story about the age of the Earth. How old is the Earth? This has been a question that has been on the minds of humans as long as humans have been curious and asked themselves questions about the universe. I mean, when you think back on your own lifetime, you can't remember the very first year of your own life. You may have a fragment of a memory from the first, 2, 3 years of your life, maybe, if something really significant stuck in your mind. But in your own lifetime, well, great. You students can remember back less than 2 decades for sure. And me being an old adult, I can remember back 5 decades or so. And a really old person who isn't suffering from dementia or Alzheimer's, they can remember back maybe 7 or 8 decades. And anything beyond that, you have to rely on something that you haven't personally experienced. You could rely on your parents explaining to you, well, they are, 2, 3 decades older than you are, and so they can relate to you their direct experience of history before you existed and give you some confidence that yes, the earth did exist before you were born. And they can relate to their grandparents. And so if you believe your parents and in their existence before you were born, then great. And if you believe their belief in their parents before they existed, then you could believe that humanity existed for hundreds of years into the past before you even existed. If you have faith that the written history of the world really took place when we tell you it did, then human written history spans back thousands of years now, not just hundreds. But written history doesn't seem to go as far back in time as we think the Earth existed. So how do we deal with that? Well, there is a humorous in modern times religious statement that came out where, and I'm sorry, I've forgotten the details, but once upon a time there was a devout parishioner, and she went and asked, I believe it was the Bishop of Usher. In fact, I'm going to Google this right now and see if that comes up. And I spelled it wrong. Of course, it's with two S's. The Bishop of Usher. And he was born in 1581. And so what happened was he was asked by one of his parishioners, what is the age of the earth? And so what he did is he went and opened up the Bible. And according to the Bible, Adam and Eve were the first humans. So first God created the universe, and that took like 6 days or so, and then the seventh day he rested. And then he got busy again and he created life on earth and he created Adam and Eve. And they had two children, Cain and Abel. And I think one murdered the other. I'm sorry, I've forgotten the details. And then they had kids, and then they had kids, and they had kids. And so he calculated how many years went by, how old were Adam and Eve when they had their kids, how old were they when they had their kids, and so forth. And so he added up all this time, worked through the flood with Noah, worked up through, Christ and on, all the way up until uh, the current year, which was somewhere in the 1600s. And based on his reading and interpretation of the Bible, he said that the earth was about 5,650 years old. And that's how he came up with his answer. And he really wanted to make it sound like he really knew exactly how old the earth was. And so on our modern calendar, based on when he did this and such, they're saying that this is something like the year 4004 BC, which used to mean before Christ. Uh, and I'm just staring at the Google results that came up. And then to make it sound like it was really, he really nailed it. He said, "Oh well, it was actually on October 23rd of 4004 BC." And then he wanted to make it sound like he super nailed it. So at the beginning of night, so he actually said something like 9 a.m. or 9 p.m. as the date on which the Earth was created. So there you go. Well, this is something, right? And how can you dispute this by looking around you, using your senses, using the scientific investigation skills that we're trying to impart on you, your critical thinking skills? How would you challenge this assertion that the Earth was created uh, less than 6,000 years ago, which is a tremendously long time ago? Well, so science has evolved over the years, and there are certain things that we have learned. We have learned, for example, that a tree, imagine that that's a tree, every year that it's alive and it grows, it adds another ring to its trunk. And so if you cut the tree and count the rings, we have it throughout human experience, we have observed it's only one ring per year, never two and never less than one. So we have our faith that every tree ring represents 1 year of growth of the tree. Now, if you believe that trees can't exist before the earth existed, then you could count tree rings and argue that, well, the earth must be at least that old. Now, trees themselves might only live for 100, 150 years. There are some trees in the state of California that are the oldest living things on this planet that we know of, unless you want to count the great coral reef of Australia. That is a living organism, and that one might be the oldest living organism. But trees in the state of California are as old as 2,300 tree rings, which means they're by themselves 2,300 years old. Now, one thing we've learned is that the the appearance of each ring is related to the growing conditions during that year. So if it's a good year, maybe it's a healthy, robust looking ring. If it's a terrible year as far as weather and conditions, then it's a wimpy type ring. The tree doesn't have good growth. Maybe it's a drought. So one nice thing is that if a tree lived even earlier and then died, if we look at the dead log of this old tree, we can make a connection between the last rings of its life and the first rings of a life in the tree that has some overlapping time with it. So maybe the last 10 years of this tree, the growth rings match the pattern of the growth rings of this tree during the first 10 years of its life. And so by this technique, we've been able to establish that trees have been growing for thousands and thousands of years, not just uh, hitting this limit here, but going beyond this limit. So, what the Bishop of Usher was able to figure out by reading and interpreting the Bible is now not in agreement with what we uh, estimate using scientific observation and methods. And so, sadly, this leads to a conflict uh, at some level amongst humans, saying, well, the Bible is the description of our universe, and therefore science should be overruled. The universe, the entire universe, the Earth, everything was created on October 23rd, 4004 BC, according to the Bishop of Usher, and that's good enough for me. All right, had to make it rhyme. So, how do you resolve this conflict? The way I view it is that science tries to explain to you how the universe works, and religion tries to explain to you why you are here. And these are not the same thing. Within the context of religion, if a parishioner asked someone like the Bishop of Usher, what is the age of the earth? Well, he's trying to accommodate a parishioner who's asking a science question, but he's really not qualified to provide a science answer. So he worked out an answer that would be, let's say, satisfying from a religious viewpoint that says, okay, here's an answer. I'm happy. I'm going to continue my praying, and life is good. The world of science is different from religion because these are different questions. As a scientist, I can't tell you why you're here. I can tell you our best theories and explanations about the age of the earth and the creation of the earth and the creation of life and how you came to be, but none of that explains to you why you are here. What is your purpose? What is your um, hopefully positive contribution to life in this universe? For that, we recommend you turn to religion and don't misbelieve, like some people do, that it's one or the other. Many of the world's most prominent, famous, successful scientists were simultaneously deeply religious. So don't think only atheists are science. That is so far off the mark. You should just Google it if you don't believe me. Uh, you know, Pick some scientist and see, what was their religious beliefs. Okay, you'll soon see that how is not why. Science, religion, two different questions, two different ways of working with the universe. So I'm not going to continue with the religious um, answer. Instead, I'm going to talk about the science pathway. So we can figure out that trees have been around for thousands and thousands of years. And we can start to look at rocks. So one of the things I did during spring break is I went on vacation to Bryce National National Park in Utah. And while I was there, I also visited Zion National Park. And I even took a picture, which I should share with you students right now. And what it shows was something like layers of rock that went sort of like this, and layers of rock that were right on top of it that went something like that. This is called a discontinuity. So, what we believe based on geology is something called uniform deposition. The idea is that geologic change occurs murderously slowly over time. That there isn't suddenly a mountain that pops out of the ground. There isn't suddenly an ocean spanning thousands of miles. No. Geology believes more or less things change slowly over time. Now, it's true that just a few days ago was a major volcanic eruption in the Caribbean, some volcano that hadn't done anything for, I think, hundreds of years. I, I forget the details. But today, or this, within this past week, it's been creating havoc on the local people with its ash and all the side effects of a volcanic eruption taking place. So, on the geologic scale of things, okay, so if it erupts once every couple hundred years, that's that's still not a big sudden rapid change in things. It's like, okay, every few hundred years or so it erupts. Interesting. Uniform deposition sinks, if you have something like a mountain at the edge of a continent that goes to an ocean. Okay, so here's the shore, here's the waves of the ocean, here's the bottom of the ocean's bottom. Great. Uniform deposition says, look, every time it rains, every time the wind blows, there's erosion and the plants grow. And ice in the winter seeps into the cracks of the rocks and it breaks them apart and it makes them fall down by gravity. And the rivers flow and into lakes and then the lakes out to the ocean. And so debris from the mountains fill up the bottom of the oceans. And that this is a very, very slow process of erosion. So we believed for a long time that if you wanted to find the oldest rocks on Earth, if you could somehow ask a rock, what is your age? That the expectation was you would find the oldest rocks at the bottom of Earth's oceans because they eroded down there first. And here's new rocks. Here's the rocks that have just been added to the ocean. And here are the oldest rocks. Turns out this isn't what we found out. We eventually learned how to ask a rock what its age is. Turns out rocks are clocks. But before I get to that, I do want to talk about this geologic principle just a little bit more. Generally speaking, it is true that the lower the rock, if you were to, um, cut away a mountainside and look at the side of it, the lower the rock, the older the rock. So the older ones tend to be down below, the lowest that you can see. Newer, newer, newer. So what happened here at this discontinuity is there used to be probably more and more layers above this one. And the whole region sank, turned into rock, it rose, it got worn away, and then it sank again. And this time the wind built sand dunes as it rose again. So it went down, it went up, it went down. Now, as it went up again, sand dunes formed this banded sideways pattern. And then it sank again and turned those into rocks on top of these rocks. So all of this is the interesting study of geology. And in geology, you learn there's three types of rocks. There's, oh gosh, igneous rocks and metamorphic rocks and sedimentary rocks, right? So igneous and metamorphic. I don't know if you already studied this in an earlier science course, and then sedimentary. Sedimentary means it's using mostly water, but maybe sometimes wind to be transported to a place where eventually temperature and pressure go up and it turns into a rock. Metamorphic means it has the temperature's gone up enough and the pressure enough to partially melt the rock. And then maybe it came back up towards the surface and was interesting uh, taffy shape to it. And then igneous means it's like magma from a volcano. It oozed out. Now we can have all kinds of complicated things take place in geology. We can have a volcano uh, rise up through all these rocks with a column of magma, and maybe it reaches the surface and maybe it doesn't. So geology is a complicated field to study. I'm going to pause for 3 minutes right now. All right, closing our 3 minute break, resuming. Geology is fun. Please, if you get the opportunity to take a geology course or two, do so, particularly when you can learn about your local geology wherever you are living. I think I'll just briefly mention the fossil record. So there exist sedimentary type rocks that have fossils in them. And from these, we've established that just like older rocks are at the bottom, older, let's see, lower fossils are older than the fossils above them. That the fossils show greater uh, finesse, shall we say, in what's called the geologic timescale. So you can look at a bunch of rocks. You go to the Grand Canyon and you see they have certain patterns to them. You go to Zion, you see they have certain patterns to them. And overall, around the globe, we can say, oh, uh, this pattern means it's the oldest set of rocks. The pattern above it is, the younger, younger, younger till you get to the top of the pile. It doesn't tell us how old the Earth is, but it does give us a relative scale that says the rocks from this bottom layer that we can find are the oldest rocks around. Fossils just contribute to that rock scale by providing richer details on each layer. It says, oh, here's where the trilobites were. Here's where the dinosaurs were. Here's where the first trees were. Here's where the first flowering plants were. And so it just fleshes out the details about the progression of life on Earth. But the part that really lets us figure out the age of the Earth is the fact that rocks are clocks. And so, what I mean by that is that when you look at the periodic table, you might vaguely remember that for hydrogen, it says its atomic mass is 1.008. Well, what does that mean? It means it's really a combination of an isotope of hydrogen that is 1 exactly, and an isotope of hydrogen that is 2, but not much, right? Like point less than less than 1% of all naturally occurring hydrogen is something that has a neutron as well as a proton. So you might vaguely remember this is the sum of neutrons and protons. This is the number of protons. So if the mass number were 1, that means all it is a proton. If the mass number were 2, that means it's 1 proton plus 1 neutron. Well, great. So the elements on the periodic table can have different numbers of neutrons. Some of these are radioactive. Carbon 14, for example, is something that has 6 protons and 8 neutrons, whereas carbon 12 has 6 neutrons and 6 protons. I'm pointing here, 6 protons and 6 neutrons. 6 protons, 8 neutrons. Well, this carbon is radioactive. And if I recall, its half-life is 5,370 years. But Lord Google can confirm if that's the right number. And so what does that mean? Well, it means that if I start with 100 grams of carbon 14, then after a time period of 5,370 years, half of it will have disintegrated into something else. And if I go another 5,350 years, half of that will disintegrate into something else. And every 5,370 years, half of it disintegrates into something else. I forget specifically the daughter product, maybe nitrogen 13, whatever it is. So here's some interesting things. The Earth is surrounded by an atmosphere, and this atmosphere has, carbon dioxide in it. We've got water in our atmosphere. We've got lots of nitrogen. We've got oxygen, which, by the way, is a byproduct of life processes on Earth acting over a long time. The Earth is getting hit by radiation from outer space. We believe the rate at which the radiation is hitting the Earth is a constant. So a little bit of science faith there. We have no reason to believe that it's not constant. So this radiation includes, like gamma rays and cosmic rays and all kinds of good stuff. This radiation from outer space tends to create carbon 14 as a result of hitting just the right molecules on occasion in the Earth's atmosphere. Well, you breathe the Earth's air. Trees breathe. In fact, all aerobic life processes on Earth breathe air or breathe oxygen, if you like. And as long as you're breathing, your ratio of carbon 14 to carbon 12 is maintained at the rate that it's the ratio that it is in the Earth's atmosphere. When you die, you stop breathing. Ta-da! And that means whatever carbon 14 you have in your lifeless body decays, but the carbon 12 does not decay. So let's examine your dead body. When we look at your dead body, we say, oh, look at this. 25% of the carbon that's in your body is in the form of carbon 14, and 75% is in the form of carbon 12. So you can look at my little picture here and say, well, after 5,370 years, 50% of your body is uh, carbon 12. After another 5,375 years, 25% of your body is carbon 12. So if 75% of your body is still carbon 12, that means you are between 0 and 5,300 years dead. That you died, that you took your last breath between here and there. And yes, there's a math formula for calculating the year that you died based on half-life. I think it's something like oh one what 1/2 raised to the teeth power is the ratio of uh, final to initial, something like that. I'm sorry, we don't care today about it. I just want to remind you that there is a math formula. You were supposed to have it in your chemistry course, and it relates your half life to the ratio of these two isotopes. Okay, so how did we figure this one out? Well, the answer is we had those trees, the ones that were dead, the ones where we knew how old they were when they were planted, the ones where we knew when they were planted compared to human history. Oh, this tree was planted by my great 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 grandfather in the year da 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 da, or this tree was, So by working backwards through time, we established this 5,300 years. We were able to calibrate it. And this is great. We use this for organic matter on the surface of the earth. So this works for humans. This works for trees. This works for anything that was breathing the air on our planet. And so from this technique, we can find a fragment of a bone, a skeleton, a tree log, and establish that it lived and died hundreds of thousands of years ago. Now, as you get to tiny and tinier fractions, then it becomes harder and harder and harder to be precise in your dating, relative um, dating. So now I'm going to ask Lord Google, uh, you know, what do we do? Well, it comes back to this wonderful statement: rocks are clocks. So it says when radioactive decay was discovered in 1896, that was the start of figuring out how to use rocks as clocks. So It says it uses potassium argon for a lot of stuff. And so this is great because the daughter, anyways, and by the way, I'm looking it up. I have the wrong number here. It's not 5,370 years. It says it's 5,730 years. So there's a correction to my error. Sorry. 5,730 years is the half-life of carbon 14. And it reverts to nitrogen 14 if you're interested. So cloth wrappings from a mummified bull taken from a pyramid in Dashur, Egypt. Charcoal from Crater Lake that a tree burned during a violent eruption. Charcoal from a rock site in southeastern Washington state. Oldest known inhabited sites in North America, 10,130 years old. Spruce wood from Wisconsin, 11,640 years old. The Bishop Tuff, I've gone and seen that. It's in Owens Valley, California, 700,000 years old. Volcanic ash from East Africa, 1,750,000 years old. So wow, we are so far off the time scale of the Bishop of Usher. Monazite from Bingham-Canham, Utah, 37 million years old. Samples from Half Dome in Yosemite National Park, 80 million years old. On and on and on. The bottom of this list is 3 million, I'm sorry, this is 3 billion years old. So some of the oldest rocks that we have dated using radioactive decay. So I used carbon with living organisms as the example for life forms. For rocks themselves, I'd mentioned this, oops, wrong mouse, potassium argon stuff. So potassium argon, uh, I'm not sure what the half-life is for this stuff, but it works well. Argon is a gas, potassium is a solid. So when the rock is formed, it begins as a certain quantity of potassium, no argon. And as it decays, after one half life, half of it is turned into argon gas. After two half lives, half of that, and so forth. So the math stays the same. It's just the value of the half life has changed. So they've been able to date rocks on Earth that are at least 3.2 billion, that's a billion, not a million, years old. So science is vastly different from religion in, the short answer, what is the age of the earth? And how do we come to believe that this is the age of the earth? And this isn't the end of the story. This is just what I see on Lord Google as being the oldest dated rocks that we can find on the surface of the earth, where we can still date them using radioactive decay techniques. There are additional uh, arguments, you could say, that have been made to refute shorter periods of time. For example, when you look at uh, evolution, and try not to think of this as being a bad word. Oh my goodness, he's using the word evolution. For example, the very first bicycles, you basically were walking with your feet on the ground, and your body was somewhat supported by a pair of wheels. And then, they evolved. So there's a famous bike design that had a huge front wheel and little tiny rear wheels. And they evolved. And by the time I was a tiny tot, we had 3-speed bicycles, and they've evolved. And now you have 20-speed bicycles, and you have bicycles where you lay back and you're almost horizontal to reduce wind drag. And so that's just evolution of a piece of technology. Your laptop that you're using to attend class has evolved. And if you go off to college, you're probably going to want to get the newer model, more capable, faster, similar price or lower. Everything evolves. Your television at home has evolved. When I was a tiny tot, I began with a black and white television that had a tube in the back of the TV. So the TVs were shaped, well, they had an electron gun here that fires onto a phosphorus screen that glows when it's hit by streaming electrons. It is physically impossible to use this technology to create the flat screen TVs that you're so used to. Even your cell phone uses flat screen technology that didn't exist. Back in the 1930s is when television was starting to be invented or so. 1930s, I believe. So this is just another example of evolution of technology. Well, evolution applies to life forms as well, at least in the world of science. So we can look at the shape of a horse and say, oh, according to the fossil record, small horses existed before big horses existed. They began as small horses. And by the way, the plants that are also fossilized with those small horses is the kind of plants that would be appropriate for small horses. And the fossils that are associated with big horses are related to the types of plant fossils that would be appropriate for big horses. So it's a consistent story. It makes sense. It's believable. If you can see technology evolving, then you can see life forms evolving as well. Now, religion takes a viewpoint that says uh, the fossils and current life on Earth were all made simultaneously, and that the fossils were just placed there, maybe as a humorous diversion for human intellect to ponder, but that really the Earth was all created in one day or a week or so. The science viewpoint is, well, God, the universe was created over time, and it is evolving over time, and it's still evolving. So not only technology, but uh, you know, uh, even life evolves over time. And so our current belief is that about every third generation of humans is has a mutation somewhere in the genetic code, and maybe it's a harmless thing, maybe it's a harmful thing, maybe it's a beneficial thing, but genetically uh, changes take place. And if the conditions favor a type of mutation over time, then that one might tend to become uh, the one that survives the best. Oh, was it Charles Darwin? I think had the phrase "survival of the fittest." Well, that could be. It's used in the science field as an argument against a short age for the Earth. In the science world, it says, you know, evolution of life is a very slow process, like geology. You don't suddenly become uh, drastically different if you start living on Mars. You're still going to be an Earth based human being. You're not suddenly, your kids aren't going to be 10 feet tall if you move to Mars and you have a kid. They're not suddenly going to be 10 feet tall. They're going to be normal Earth based human height, even if they're born on Mars, which only has 3/8 the gravity of the Earth. I have people, seriously concerned about that, but you should not be because evolution is so gradual for the most part. So the science argument is you can't have the evolution record that we see fit into a time span of just 4,000 years or so. It it just doesn't happen that fast. Once upon a time, there was a scientist who said, "What if the Earth were made out of molten iron at first?" Well, he studied iron, and he was just guessing. Suppose the Earth were made out of iron, and I start with it molten because we see magma coming out of the Earth, and so we can believe, yeah, the inside of the Earth is still hotter than the outside of the Earth, the crust where we live, and it is. It actually gets very hot inside the Earth. I believe it's even hotter in the center of the Earth than it is on the surface of our sun. Crazy, right? And so what this guy did is he poured molten iron into a mold, and then he hired, I believe, some pretty girls, and their goal in life was to report to him how much time it took place from when the iron was freshly poured to when it had cooled down enough that it was just warm, that they could comfortably hold it in their hands and not burn themselves on hot iron. So, it takes some amount of time for it to cool down. And he wasn't trying to get them to burn their skins. He was trying to, be cautious, be careful, don't touch it, just give it a quick tap when you're ready. And so he measured that amount of time. And then he scaled it to the entire planet Earth. And he said, well, we stand on the entire planet Earth. So it's got to be cooled down to at least this much where it doesn't burn your feet to be standing on the Earth, right? And then this is just simple math, a little physics, but math of ratioing and scaling and saying, well, the rate at which the heat was being emitted from a sphere of this size, the rate at which the heat is going to be radiated away from a sphere of this size, how much heat do you need to get rid of? What's the rate at which it goes? So from this, how much time do you need to cool the earth down from being molten to being the surface that we can walk on without burning our feet? And so the point that I want to make is his answer also worked out to be much, much greater than what the Bishop of Usher was stating as being the age of the earth. So if you believe that the earth began as molten and that now the crust of it at least is solid and cool, and if you have faith in this scientific measurement and calculation, it leads you to believe the earth is once again at least hundreds of thousands of years old, if not older. Okay, so all of this is just one little tiny piece of the entire universe. We're just trying to figure out, well, the universe should be older than the earth, right? And if all of this leads us to believe that the Earth is billions of years old, then the universe in which the Earth exists should also be billions of years old. Now, of course, I can just give you the number out of the textbook that says, we believe the age of the Earth is dot, dot, dot. But I wanted you to have an understanding of how we've come to make that claim. And I almost feel like closing out today's session with kind of a humorous joke about how old I am. And the joke goes something like this. Students, when I was your age, the age of the universe was 9 billion years old. Okay, when I was your age, the age of the universe was 9 billion years old. And now the age of the universe is 18 billion years old. And so the humor of this joke is that means I am really, really old, right? I must be 9 billion years old. But what the reality is, this is around the number that we believed to be the age of the universe back several decades ago. And over the past several decades, our estimate of the age of the universe has increased a little bit, maybe 15 billion years old. Maybe it started at maybe 12 billion years old. But over my lifetime, the estimate of the age of the universe has increased by at least a few billion years from when I was first, learning this stuff. So this is a humorous way to express it. Oh, I'm so old that when I was your age, the universe was only 12 billion years old, and now it's 15. Yeah, okay. So that concludes today's exciting educational lecture. All of this kind of kicking off our study of the sun, because think of this. We don't believe the Earth existed before the sun existed. So I think in my next talk, I want to explain how pondering what makes the sun shine as bright as it does for as long as it has been shining, right? It's got to shine for billions of years. All right, there's the bell.